through an endless expanding existence of time, space, and matter. Every day, new discoveries are unlocking the mysterious, the mind-blowing, the deadly secrets of a place we call the universe. Could our sun have an evil companion? An undiscovered Death Star rotating at the furthest edges of the solar system? Does this mysterious star scatter destruction through the solar system at regular intervals, accounting for the greatest extinctions in Earth's history? Sifting through a realm populated by giant worlds and mysterious planetoids, scientists are on the hunt for Nemesis, the sun's evil twin. Of the billions of stars twinkling overhead, one may be a scourge to life on Earth, an evil twin to the sun named Nemesis. Some scientists suspect that Nemesis is a dark, still undiscovered star orbiting our sun. And every 26 million years, it triggers a disaster.
We know that the solar system is surrounded by this enormous cloud of comets, and so these successive passages of the sun's companion would send comets into the inner solar system. Some of them would hit Earth.
What follows is death on a colossal scale. It is now widely accepted that a rock from space caused the end of the age of dinosaurs 65 million years ago.
So we now are pretty convinced that the reason that a huge fraction of life on the Earth went extinct 65 million years ago was because a comet slammed into the Earth.
But astronomer Richard Muller has proposed a revolutionary theory to explain why that space rock crashed to Earth at that particular moment.
The Nemesis theory postulates that there's a star orbiting the sun at a 26 million year period. That's about it. Almost no other assumptions need to be made.
Muller believes that as Nemesis nears the sun, its gravitational disturbance sends comets flying through the solar system. The resulting impacts have been the source of many major extinction events in Earth's history. Muller explains how the theory came about.
Two paleontologists, when looking at patterns of extinctions, came across something that seemed utterly insane. They said that similar extinctions were taking place every 26 million years on a regular schedule.
The discovery of a 26 million year pattern of extinctions seemed impossible to explain by any process native to the Earth itself.
This is the sort of thing you dream about in science. It means there's something we don't understand. It means there's a discovery waiting. So I set about trying to figure out what that was.
Muller made an astonishing proposal. The only logical cause of these periodic extinctions is a cosmic stalker that orbits our sun every 26 million years, disturbing the comets on each approach. In short, a Death Star companion to our sun.
If this star is discovered, it is so important. It was a major player in the evolution of life on Earth. Without this, perhaps the dinosaurs would still be here.
If Muller is right, humanity itself could owe its existence to the Nemesis Death Star. After all, each mass extinction wiped out vast numbers of species, but each also cleared the way for new species to arise, including, ultimately, humans. We can witness the way Nemesis would have altered evolution on Earth by looking at a controlled burn on the Santa Rosa Plateau in California.
So every now and again, some cataclysmic event happens that wipes out a huge number of species here on Earth. And this is just like happens with these controlled burns, where the burn wipes out a number of species, which then makes room for new things to take hold. So, I'm seeing a fire raging behind us. What's going on there? Why do you light fire?
We're out here setting this fire to clear part of this vegetation away to get rid of the non-native species of plants that are growing here so the native can grow back. We come here and burn annually in different plots of land so that it can be studied, and we can also see the impact it's having on that environment.
A prescribed fire mimics the kinds of mass extinctions that Nemesis may have caused. Many species are swept away, but the destruction leaves room for the survivors to flourish and evolve. Just as mammals survived and thrived after the fiery death of the dinosaurs, setting the stage for human evolution. These prescribed fires return to Santa Rosa every year and imitate the driving motivation behind the creation of the Nemesis hypothesis, that extinctions occur over and over.
There are really only two viable explanations for the regularity of the extinctions. One of them is the Nemesis theory. The other is that by the throw of the dice, they just accidentally happen to line up every 26 million years.
But how exactly would Nemesis trigger extinctions with the regularity of a prescribed burn? The possible answer lies in a region of the solar system known as the Oort cloud.
The Oort cloud is the place where comets are kept in cold storage until they come screaming in towards the sun. So these things are sitting in deep freeze, sort of at the distance halfway between us and the nearest stars.
The vast majority of Oort cloud comets orbit at the safe distance of up to 1 light-year from the sun. That is, unless something disturbs their orbits.
Occasionally a star will come by and they'll get a little bit jostled, and then little jostling can do a lot of things. It can make them go away and leave the sun entirely. It can put them on a slightly different orbit. But one of the things it can do is put them on an orbit that slowly falls in toward the sun.
By following the motions of a juggler, astronomer Greg Laughlin can help visualize why cometary orbits are so vulnerable to the effects of a passing star like Nemesis.
Hey, Greg. So this is Josh Horton, and we've enlisted Josh to kind of help us understand how the Oort cloud really works. How many balls are you actually able to keep up in the air at one time?
That was 7. I can do a little bit of 8 and 9, but 7 is what I practice the most.
The arc of something that a juggler is tossing up is very much like the arc that a comet makes on its eccentric orbit, especially because it's going slow near the top and it's going very quickly near the bottom. If we want to simulate the whole Oort cloud, then we've got to keep a lot of balls in motion. So I'm wondering if you can maybe give me a quick
Yeah, I can
lesson.
try. Okay, well, let's start with 2.
2 balls.
So what you're gonna do here is you're gonna cross both balls in here. So it's gonna be throw. No, the throws are exactly the same, just like the path of the comet. So cross, cross. And they're making an X in the air.
Do they leave at the same time or
No,
different times?
it's right, left, catch, catch.
Right, left,
Yeah, that was it. Just throw your left hand a little
right,
bit higher.
left, catch, catch.
Good. They're kind of catching at the same time.
Right, left, catch, catch.
That was better.
So I'm a little bit like a solar system where there's some serious gravitational instability in the mix. So Josh is keeping 7 balls in the air at the same time, and that's not unlike the sun's job, which is to keep trillions of comets all orbiting in the Oort cloud.
But according to the NEMESIS hypothesis, the sun's delicate juggling act is disrupted by its evil stellar twin every 26 million years. And like something out of a horror movie, this evil twin could be nearly invisible. Does our sun have an evil twin? A star named Nemesis orbiting the distant reaches of our solar system? And every 26 million years, does it fling comets from the Oort cloud toward Earth?
Sometimes they get tossed out, other times they orbit harmlessly until they evaporate and go away. If you have comets rattling through the inner solar system, then in a sense all bets are off.
Scientist Richard Muller not only theorizes that this periodic mayhem is caused by a deadly companion star to the sun, he believes he knows precisely what kind of star it is: a red dwarf.
That there is a star orbiting the sun in a 26 million year period, that was my idea. Let's assume the star is a red dwarf star. Why red dwarf? Because that's the most populous star in the galaxy.
A red dwarf is a tiny star that weighs in with a mass less than 1/10 of our sun. But as astronomer Greg Laughlin demonstrates, it can have the effect of a 9-pound bowling ball tossed into the arms of a juggler playing with fire.
All by itself, the Oort cloud is a pretty boring place, and so we're going to have to up the ante a little bit. So these are going to represent the comets in the Oort cloud.
You ready?
I think I'm going to step back a little bit. So Josh has got them all going nicely, just like the comets orbiting in the Oort cloud. So let's see what would happen if I took this red dwarf and tossed it into the solar system. Josh, are you ready for the red dwarf?
Yeah.
Here we go.
Oh.
So as you can see, the red dwarf coming through the solar system has really changed the orbits of the comets. Notice that 2 of these comets actually crashed onto the Earth. That's not unlike what happens when a giant impact occurs and we get one of these mass extinctions.
For many people, the idea that Earth has been the victim of a series of impacts caused by an orbiting Death Star seems unlikely. After all, when we look at the sky, we only see one sun. But in fact, the majority of stars come in pairs.
Probably something like 60–70% of stars may indeed be binary or have even higher numbers of stars in the system.
According to Richard Muller's NEMESIS hypothesis, our sun is part of such a binary star system.
It all works. All you have to do is hypothesize that the sun, like 2/3 of all the other stars in the galaxy, has a companion. This one with a 26 million year period, and there you have it.
But if so, why don't we see the sun's twin in the sky? According to Muller, the reason is simple. Nemesis is an extremely dim red dwarf.
When I first came up with the Nemesis theory, the issue was, well, wait a minute, how come nobody found it? And that was pretty obvious. It has to be hard to find.
By definition, a red dwarf barely glows at all.
It would be the closest star to our sun, and we wouldn't even know it. Now, why is that? The way we discover nearby stars is either because they're very bright, and a red dwarf star is not very bright, or because the sun is moving past it. This star is moving with us. Yes, it's orbiting us, but that orbit is very slow, 26 million years. So it would be moving with us. It would just be at a fixed position in the sky and wouldn't move.
In other words, when viewed from Earth, most nearby objects are shifting over time. But Nemesis is sitting still. So, as the search for Nemesis enters high gear, one key question is where to look. Luckily, scientists understand how binary stars orbit each other, and they can apply this knowledge to the search for Nemesis. If both the Sun and Nemesis were of equal mass, they would orbit each other in a vast but equal circle, and the search for Nemesis would be relatively easy. But binary stars are rarely equally sized.
10 or 20% of binary stars have two components where the stars are really on an equal footing. And then there are also a large number of stars where one star is considerably more massive than the other.
When binary stars are of different sizes, the smaller star, in this case Nemesis, swings in a wide orbit around its larger companion, in this case the Sun, which barely seems to orbit at all. Why does the smaller one move in a much wider circle? The answer has to do with a concept called the center of mass. A pair of gymnasts on a balance beam can help us visualize how it works.
Stars in a binary pair orbit around their common center of mass. If two stars are about the same mass, they orbit around an invisible spot in the middle, right in between the two of them, just like Tammy and Carly are balanced on this seesaw. Wow, are you guys balanced?
But unlike these gymnasts, Nemesis and the Sun are not equal. Astronomer Richard Muller estimates that the Sun has 10 times more mass than its undiscovered twin. And when one binary star is larger than its sibling, the center of mass between them shifts closer to the larger star.
So Tammy's going to help illustrate that. Tammy, how much do you weigh?
About 130.
About 130. And we have weights at this end that are about 35 pounds. So you're just a little bit less than 4 times that weight. So climb on up. Let's see where you have to be to balance the balance beam.
Since Tammy weighs about 4 times as much as the metal weights, she must move far closer to the center of mass to maintain balance. If Tammy and the weights represented binary stars, the weights would orbit far out in the distance, while Tammy would barely move. In fact, both would be orbiting each other.
It's kind of a misconception to think that the more massive star doesn't move and the less massive star just goes around it. In fact, they're still both orbiting the common center of mass. The more massive star moves less, and the less massive star moves more.
This insight is key to calculating where Nemesis might lie in relation to the Sun.
We know it's a 26 million year period. That tells us how far out it is. It has a radius of about a little over light year. So we know the orbital size.
Now that scientists know roughly where to look, the search for Nemesis is in full swing. And so far, that search has led to an astounding new theory. Not only might the Sun have an undiscovered twin, the solar system may be harboring a massive undiscovered planet. In the hunt for an evil twin to our Sun that shakes comets loose and rains death across the Earth, all of the pieces are in place, except one.
The Nemesis theory really needs the smoking gun of actually finding direct evidence for the object itself in order for the whole thing to hold together.
Now, why haven't we found it yet? And actually, there are quite a few astronomers who don't pay very much attention to this and simply assume that if it existed, it would have been found by now. We believe this thing can be found within the next few years. What it takes is a survey of dim stars.
Enter WISE, the orbiting wide-field infrared survey explorer. a powerful new tool that just might crack the NEMESIS mystery.
The reason that WISE is going to be so good is because it operates in the infrared. It sees heat, basically.
By measuring heat instead of light, infrared scanners can make warm but dark objects easy to spot.
The nice thing about looking in the infrared at the heat of it is you don't care how far away you are from the sun.
Jupiter provides an example. The temperature on the surface of Jupiter measures 230 degrees below 0 Fahrenheit. But that's blazing hot when contrasted with the 450 degree below zero temperature of space. So even in the absence of sunlight, a distant Jupiter-like planet would glow brightly in the infrared. By visiting a motor speedway, we can see how the WISE survey might help find NEMESIS by exploiting the infrared contrast between objects of different temperatures. Here, the roar of the engine only tells half the story.
I came out here today to the Drive Tech Racing School to be in a race car that would go zooming around this track a bunch of times. And the idea was to film the car with an infrared camera and show us things that are hot, hotter than the outside surroundings, and glowing at infrared wavelengths. Good to meet you.
Likewise.
Yeah, you're the driver?
Sir.
Now, how fast are we going to be going?
Approximately 170 miles an hour.
Now, that's about 3 times normal highway driving speed,
Yes,
so
sir.
whoa, things are really going to heat up.
Oh, yeah.
All right, let's go then. Blair Dupree of Drive Tech helped me get into the car. This is a nice thick helmet, huh? And it's not so easy because there's no doors, okay? You have to kind of climb in through a window.
Bring your left foot up in there.
Okay.
Bring your right foot on up.
I feel like I'm breaking into a car. And then kind of slither your way in. Being in that race car was really exciting. When I was going around the turns, I could really feel the G-forces.
Ted, give you a good ride, didn't
Yeah, well, I'm glad Ted was the driver. I couldn't do this, you know? I was scared out of my seat and I wasn't even the driver, okay?
With the car nicely warmed, a FLIR infrared camera, set up by thermal imaging expert Ross Overstreet, sees everything literally in a new light.
Hello, Alex. Hey, Ross. How are you doing?
Doing good. How are you doing?
Good, good. Let's look at these infrared images.
Right now we're pointed at the back of the car. The best way to think about it is it's more of a measurement device than a camera. It's like having 1 million different thermometers spread across the image. We're actually getting temperature measurements on each of those pixels. Things that are supposed to be hot look like they're glowing. They're red and orange and white. And things that are cold are colored blue and black, and colors you associate with cool objects.
Right.
And you'll notice there's several different hot areas of the vehicle.
Now, I see some variations across the tires.
Yeah, and you'll notice that the one tire is a little bit warmer than the other.
The right-hand tire was indeed hotter than the left-hand tire because there was more pressure on it during the turns. So how hot is that hotter tire there?
We made a measurement earlier of about 190 degrees Fahrenheit, almost the temperature of boiling water on the tires.
When we just look by eye, we can't tell whether something is hotter than something else, but here you can tell, and that's really cool.
Right, this camera would work just as well if it was pitch black or in the middle of the day. It doesn't care about solar light at all.
The infrared camera sees the racetrack the way the WISE survey scans the dark and faraway realms of our solar system. If NEMESIS is out there, infrared should reveal it.
The hot spots of the race car are sort of like warm, glowing objects out in the cold depths of space, far from the sun. This is a whole new way of discovering objects. Objects too faint to be seen through a normal optical telescope, but bright enough to be detected in the infrared.
The WISE telescope completed its sky survey in early 2011. But in the search for Nemesis, the results are still inconclusive.
The WISE survey is going to take a long time to analyze, simply because there's a huge amount of data that had been gathered by this craft.
About half of the Nemesis candidates have not yet been studied, but in the next few years, we expect the theory will be either proven right or wrong. Until that time, it is and should be controversial.
That something so relatively near to Earth can be so obscure is what Frank Jankowski of Mobile, Alabama, wants to ask the universe. Why can scientists observe objects in space that are millions of light years away, yet have difficulty spotting objects at the edge of our own solar system?
That's an interesting question, Frank. The objects that are millions of light years away that astronomers can see are powerful and luminous. They produce a lot of energy on their own, like an exploding star. But an object near the edge of our solar system might be small, and it reflects only a little bit of sunlight, so we can't see it at visible wavelengths.
But as scientists analyze the data for signs of Nemesis, they have made a disturbing discovery. Although calculations indicate that Nemesis isn't due back for millions of years, something appears to be shaking up the comets in the Oort cloud right now. Could Nemesis already be upon us? Since the birth of the Nemesis hypothesis, astronomers have been on the lookout for a faint red star that periodically disturbs the gravitation of the Oort cloud comets. This sends them on a catastrophic rendezvous with the inner solar system, including Earth, every 26 million years. But as scientists study the Oort cloud, they have uncovered unsettling evidence that something is disturbing comet orbits right now. Has Nemesis already returned?
If the sun was all by itself and there was no Nemesis, then the comets in the Oort cloud would all have very predictable and regular orbits. They would be very regular in their arrival times and departure times.
Without gravitational interference from anything other than the sun, Oort cloud comets, like juggled objects, could spread out evenly across the sky. However, that's not what some scientists report.
When we look out into the sky and look at where the comets are coming from, their directions tend to concentrate in a certain region of the sky. And one possible explanation for that is that that skew is being directed by the gravitational perturbations from an unseen object that is out there.
Based on these observations, scientists infer that a huge object is disturbing the Oort cloud. They do this the same way that California transit officials infer that an accident is disturbing traffic patterns in Los Angeles.
So, Marco, where are we? What is this room?
Well, the map we have here on the wall, that's our freeway system map, and as you can see, it shows the major freeway routes in Los Angeles.
The green dots represent normal traffic flow, while the red dots indicate that something is causing traffic to back up.
So the speed here is just one indicator that something's going on, but to really know what's going on, you either have to have a camera or a report from somebody who's actually there and able to tell you what it is.
That's correct.
Astronomers have this problem all the time. They're trying to understand what they can't actually see. In astronomy, we frequently infer the existence of something not because we can actually see it, but because we can see the influence it has on the objects around it.
Whether too many cars are crowding too few lanes during rush hour, or an accident is slowing traffic flow, something causes congestion. Since scientists see similar congestion in the Oort cloud, could Nemesis be the perpetrator?
This place is very impressive. It's got all the cameras, all the sensor data, all the California Highway Patrol incident reports. This is far more data than astronomers have to work with. If we only had remote cameras all throughout the outskirts of the solar system, we might know a lot more about it.
Even without remote cameras, scientists have proposed a remarkable theory to explain the congestion in the Oort cloud. According to this theory, the culprit disturbing the Oort cloud isn't Nemesis. Instead, it's something equally astounding. A giant, undiscovered planet 4 times the mass of Jupiter. In short, the largest planet in the solar system. Scientists have proposed naming it Tyche.
In a nutshell, Tyche is Nemesis light. Nemesis, in the original hypothesis, was literally a red dwarf star, something that was 100 times more massive than Jupiter.
Unlike Nemesis, Tyche would not glow like a star. Instead, it would look like a strange version of Jupiter.
If you put on night vision goggles, then it would be quite a bit more impressive sight. You would see breaks in the clouds, and there would be lightning. You would see the clouds light up from the lightning down beneath the cloud tops.
Tyche may disturb the orbits of comets in the Oort cloud, but it can't be the source of Earth's periodic extinctions. First, its proposed position puts it on a 1 million-year orbit, not 26 million like Nemesis. Second, it's too small.
Tyche doesn't really have the gravitational mojo to dislodge comets, send them crashing in these periodic extinctions, really rearrange the Oort cloud. And so its effects would be visible only in these small skews and not in the form of huge pulses of comets coming out of seemingly nowhere.
Just as with Nemesis, NASA's WISE survey should be able to detect Tyche if it exists. While it's surprising that our solar system might harbor a giant undiscovered planet, it doesn't support or refute the idea that it also harbors the undiscovered star Nemesis. But a recent finding in the outer solar system may shed more light on whether Nemesis really exists and the kind of threat it may pose to life on Earth. In 2003, astronomer Mike Brown made an historic discovery when he found something floating around the night sky he couldn't explain.
I remember the day that I discovered Sedna, looking at it on my computer screen, looking at these pictures. My first reaction was, that can't be real. It's too far away. Nothing like that exists in the solar system.
What he stumbled upon turned out to be a planetoid just smaller than our moon, now named Sedna. But Sedna presents a scientific quandary. At its nearest point, Sedna lies about 3 times farther away from the Sun than Pluto, in a region where astronomers never expected to find planetary bodies.
It's the coldest, most distant place that we know in the whole solar system. If you were sitting on the surface of Sedna, you could take a straight pin and hold it out at arm's length, and with the head of that pin, you could cover up the Sun.
In addition to being in an unexpectedly distant region, Sedna also takes a wildly elliptical orbit through the solar system. The mystery is, there's nothing anywhere near Sedna that could account for an orbit that distant and that extreme.
The place where it is now, nothing ever affects it. It doesn't come close to any planets. There are no stars that ever come close to it.
So what forced Sedna into its unique orbit? And in theory, could the Death Star Nemesis have played a role? For Brown, the bounce of a trampoline offers a way to understand how Sedna ended up in an orbit that remains a head-scratcher for astronomers.
I have behind me a measuring stick that gives how high I'm going to bounce in 2-foot intervals you see here. And what that bounce is supposed to represent is how far away from the sun I am in my orbit. In a normal planetary orbit, in a circular planetary orbit, the planet circles around the sun, always staying the same distance from the sun. And that's sort of like me staying on a trampoline, I'm always the same distance from the floor. Other sorts of orbits can be, instead of going in a circular orbit, you can go in an elliptical orbit around the sun. You move away from the sun, you come back towards the sun, and so you'll be moving further away, getting closer, and that would be starting to jump up and down on the trampoline.
Like gravity keeping us in orbit, when we reach the apex on the trampoline, gravity will pull us back down.
So as long as nothing happens to me, I stay in this orbit forever, jumping up and down, always to the same height.
But something unusual afflicted Sedna. It brushed up against a mysterious force that shoved it into a region where no planetary body should exist. Some suspect that force was NEMESIS. And if the sun's evil twin is out there, scientists can tell exactly when we'll see the terrifying signs of its return. As astronomers search for a Death Star named NEMESIS that might periodically cause mass extinctions on Earth, the recent discovery of a tiny world named Sedna could prove key. Billions of years ago, Sedna revolved around our sun like other planets in a nearly circular orbit. But then, two strange things happened. First, something forced Sedna into an extremely elliptical orbit. And then something else pushed that orbit out so far that it seems to defy any visible explanation. The first question, what caused its elliptical orbit, is fairly easily explained. It could simply have been gravitational tugs from the outer gas giants Jupiter and Saturn. A trampoline can help illustrate.
To really understand how orbits in the solar system work and we get these very elliptical orbits, we need to get more height on the trampoline, and I can't do it. So Ken, I'm going to need your help.
Well, awesome. I'm ready to help.
Let me get out of your way.
Just as extra people on a trampoline create extra bounce, the large gas giants in the solar system can create enough gravitational bounce to stretch a smaller body's orbit into a wide ellipse.
So here's Sedna on a nice elliptical orbit, but then Sedna got a little bit close to one of the planets. As soon as it does that, the extra gravity of the planet gives it a little boost into an even more elliptical orbit, but then it gets close to another planet, let's say Jupiter. Here comes Jupiter. It bounces even higher. With enough bouncing from Jupiter, we could bounce Sedna all the way out of the solar system.
The orbital bounce provided by Jupiter and Saturn can explain how Sedna's orbit got its elliptical shape, but not how it ended up being forced into a distant region of the solar system, where scientists never expected to find a planetary body.
Sedna was on an elliptical orbit, getting further and further and further, and then something happened to it when it was out here. Some other gravitational force pushed it off into a different orbit, and so it didn't come back to the same place it was before.
It's as if some second gravitational force was passing by and shoved Sedna onto a different trampoline so that it bounces in an unexpected region.
The most likely answer is that there was another star very, very close to the sun at the time when Sedna was going through this process.
The solar system probably formed in a cluster of stars, and so close encounters with nearby stars, nearby rogue planets even, were much more common during the very earliest days of the solar system's formation.
Most of these solar brothers and sisters have long since dispersed. But according to the NEMESIS hypothesis, one of them is still out there, still circling the sun, still causing periodic chaos amongst the comets, and still waiting to rain death on the Earth once more. If that is correct, future generations will be faced with a monumental threat when NEMESIS returns. In 10 million years.
The moon, Mars, planets would basically be unaltered from their current condition. On Earth, the cities might not be there, but the continents would still be almost in exactly the same places that they are now.
But according to the NEMESIS hypothesis, a major change is underway, 1 light year from the sun. A dark reddish star has entered the Oort cloud. NEMESIS has returned. If humans still exist on Earth, they'll face a slow building but imminent cosmic threat.
The Oort cloud contains perhaps 10 trillion comets, maybe even more. But remember, it's really big, so if you were in the Oort cloud, it's not like you would be pelted by comets all the time. The spaces between them would be pretty big.
Like a bowling ball in a juggler's hands, NEMESIS simply shuffles some comets out of its way.
The Oort cloud has an empty region in the middle. It's been cleaned out by Jupiter and by the sun. We live in that region.
But as NEMESIS approaches, the inner solar system becomes a shooting gallery.
And so there start to be a few more comets than usual, and then suddenly there are just comets coming all the time.
And at the peak, there might be 1,000 to 10,000 comets per year in the sky.
According to the projections, Earth would be in the crosshairs of this comet storm for 1 million years.
Over a period of 1 million years, there would be visits by about 1 billion comets. Well, actually, you do the calculation, it turns out one of them will hit the Earth, 1 or 2.
It would be difficult to predict exactly when the impact would happen, but there would be this phase, this sort of danger zone in which the chances for a catastrophic impact with something of a comet size would be much, much higher than they are now.
Will the impact spark another catastrophic extinction on Earth? Perhaps, but only if we let it happen.
I like to joke that NEMESIS planned this one poorly. In between the last extinction and the next one, there's plenty of time for intelligent life to get its act together to make sure that next time NEMESIS comes back and the sky is filled with comets, to make sure that none of them hit us.
Is this future inevitable? Until scientists either discover NEMESIS or definitively rule it out, no one can know for sure.
It's important to realize this is not just an abstract discussion. Clearly, these objects colliding with Earth happen very rarely. But on the other hand, when they do collide, they're extremely cataclysmic. So what we need to be able to do is get better understanding of our solar system and keep an eye on the sky, because it may be crucial for our survival.
If the future sky one day does fill with comets, perhaps humanity will have found a way to save itself, rather than end up one more victim of the sun's evil twin.